In our first iteration, the pantry list was just static placeholders, but for this show and tell, I replaced that with a hybrid database architecture. I started by defining the core schema here in this file. For offline capability, I implemented Android Room, which is basically a database that will hold all of the items in our pantry list offline. So if I go over here, this is our database, and these are all the items that I have. So let's add something manually on our phone, and let's say I'm adding cheese to my pantry. If I press save, as you can see, after fruits, there's cheese. So all of this is great. It works perfectly fine when I add an item on my phone. But what if I want to open this app on another phone and sign in with the same account? Then I won't have this because I'm using a local Android ROM which only has a database inside my phone. But we have a solution for that as well. You see this sync button on the top? This basically syncs it to the cloud, and for that we are using Firebase's Firestore database. And here is the table in our Firebase console. So this is oranges, this is milk, this is, as you can see over here, this is apples, and this is the cheese that we just added.
Hi, my name is Arshdeep. And essentially for our project, I'm working on the pen tray fragment. So essentially what I did for show and tell 1, 2 is I implemented the scan barcode. So essentially the user can just scan the barcode for an item and it will automatically, from a library, from an API, get what kind of item it is and the category and other information if available. And it will save it to the database, as you can see here. And I also implemented the edit button here. So essentially you can edit your stuff here and also the delete button on the top. So you can delete anything, any items in the pantry. And there's also the scan receipt. So I'm in the process of implementing this. So essentially what I'm going to do is I'm going to here instead of the barcode, there'll be the receipt. You scan the receipt, you can see the preview here, and it'll parse and give you a list of all the items here with the price. And you can also edit those over here. So essentially that's what I'm in the process of doing. I'm using the Verify API to do that. I was using the Google ML kit, but it wasn't working out because I had to do a lot more work in parsing and extracting the item from here. So I just went ahead and used the Verify, and I'm in the process of working on it.
Everyone, this is my iteration 2 demo for the AI recipe suggestions feature. I'll tap generate recipes now and then I'll walk through the code. So inside fetch Gemini recipes, we fetch the data from the pantry database and then allow the Gemini to choose between if user select generate recipes, it's going to use only the database items, and if they select items right here, it's going to be select ingredients which they can use certain ingredients inside the database. And for dietary preference, it's going to be the settings options where users can select like um, vegan, vegetarian, low calories items. So right here, the first three recipe is just going to be items listed in the database, and the last two will include some of the ingredients that it needs to buy. Right here in select ingredients, when I select beef and butter, the recipe just should gonna show all the recipe with those two items. Inside build pantry prompts is where we parse all the preference and then we build the prompts from here. um, the first three is gonna be inside the database only, and last two will include some of the ingredients in the outside of the pantry. In parse Gemini response, we are gonna load the Gemini response and cut them in blocks like this, so it's easier for users to view the ingredients. So right here, only beef and butter. So when I go to settings and set preference to vegetarian and go back and click generate recipe, it should only showing vegetarian recipes. So that's the update for this iteration. We now have completed recipe generation pipeline. This make the smart pantry app far more intelligent and personalized. So right here, it's only showing milk and butter, which doesn't have beef and pork. Thanks for watching.
All right, this is going to be the presentation for the budget part of the application. So let's get started. So this is what it looks like, the budget page. It's actually fully functional, unlike from show and tell part one. So if you hit on set budget and you, for example, change the budget to something like 2000 and then you hit save, everything automatically updates, the amount remaining, the 2000, everything. You can also add purchases now and automatically adds to the Firestore database. For example, if we add something like F November 23rd and add like, I don't know, $111 in category as food or something random, and then hit save, it automatically gets added to the top. We can also add something from like November 2nd, for example, and it would automatically like add it to the bottom because it's automatically sorting by the date right now. Let's say $11 and some random category and hit save. You can see November 2nd got added here. So this is fully functional. As for show and tell part, as for the next steps, I'm planning on adding a I guess a search option where you can search by the name, and of course the ability to both edit and delete the existing purchases. You'll also be able to sort the purchases either by date or price. And lastly, the ability to filter certain purchases, maybe like more than a certain date or more than a certain amount. As for the code, I don't have time to go too in depth into it, but we of course have the purchase data class. The budget is just part of the user data class itself. I don't have like a separate data class for it. We have the two repositories, and of course we have the Firebase and the purchase repositories, which basically like just call Firebase and the Firestore to like add and do whatever's necessary. We also have the fragment view model and view model factory, and we have the purchase adapter. We also have the two we have the purchase bottom sheet and the budget bottom sheet, which is basically what you see here, the bottom sheet to like save the necessary data. Thank you.
Hi, my name is Jasleen, and I mainly worked on setting page of the app. It includes user profile, ID preference, unit of measurement, everything related to the user setting. For the app, whenever a user update anything, it uses the view model scope to launch, which calls the repository, and the repository uses callback flow to convert the Firestore backs to the flow, which leads to the state flow. When we collect the state flow using the collect function, it automatically runs on the UI thread, updating the preference reactively. See, if I change the theme to light, it updates the UI, and it also updates the Firebase right away. You see, theme light. Now let me show you the dietary preference dialog. When I type the dietary preference dialog, it opens the dialog. The dialog uses the same view model. When I save it, it calls the vm.save profile, which updates the dietary preference. The manages the user profile information like name, email, age, phone, gender, everything. The photo, when a photo is selected, the lifecycle scope launches a code routine. I'll show you 1 second. The lifecycle launches a code routine. The file IO operations read the URI path and write to the local storage. Then we run on UI thread, switches back to the UI thread to update the image view with glide. And after saving it locally, we call vm.save profile. Uses view model scope to update the Firestore. The camera activity provide a custom camera interface built with camera X. I can capture photos and images processed on the background thread using camera executor. The preview stays smooth while processing is happening. After the capture, we return the file provider UI to the activity, and then it saves as locally and updates to the Firestore. I can flip, take a picture, and it updates. We use run on UI thread to switch back to the UI thread before returning the result. This keeps the camera preview smooth while processing the image. Created reusable camera X helper, so my teammate can also use it for barcode scanning and other things. And I also added app setting manager, which my teammates can use to get the settings from the user settings page and use in their own activities. This diagram shows the threading architecture of our app. I've separated the operation into 3 layers. The top layer is the UI thread. All user interactions happens here. Button click, view updates like set image resources, loading image with glide, dialog display, post messages. This thread must stay responsive, so we never do heavy work here. Any blocking operations would freeze the UI. File operations throughout the app, like saving profile pictures and reading receipts. We use lifecycle scope to launch a code routine that runs on a file IO on the background thread. This includes reading the URIs and writing to local storage. Then we switch back to the UI thread using run on UI thread to update the view with the result. For all Firebase operations like saving user profile, preference, pantry items, or any database write, we use view model scope. The suspend function runs on background thread for network IO. The stateflow automatically dispatch the result back to the UI thread, which collect so that any activity fragment get reactive updates without manual switching. For camera operations, we use a dedicated camera executed thread. The image capture, image processing, barcode scanning all runs on this background thread. This keeps the camera preview smooth and responsive. The thread communication uses 3 mechanisms: code routine with live scope and for activity related work, and view model scope for view model work. For both provide automatic cancellation when components are destroyed. The stateflow automatically dispatches the UI thread when collected, making reactive response update update seamless. And the callback flow bridges the Firestone callback to flow, creating stream from database throughout the UI of the app. This architecture ensures smooth performance across the entire app. All heavy work happens off the UI thread and the result flow backs automatically through the straight flow, keeping the UI responsive and reactive.